Let's take a look at the 5 different tabs that you'll find in the dialog box for any of the toolpath operations you choose inside of Fusion 360. These tabs are going to be in the same order and called the same things in every toolpath operation that you select. There are 2 exceptions for this. Those 2 exceptions are going to be in drilling. You won't find a linking tab. And for lathe operations, the heights tab is going to be renamed to radii instead. So let's take a look at each one of these tabs. The first tab is the tool tab. This is where we're going to select a tool. Once we select a tool, the master RPM, feeds and speeds, and values will be populated inside of these fields. Also note that you can change the different flood types here, but your machine or post-processor needs to be able to handle those different outputs. The geometry tab, this is where we are going to select the geometry that we are going to machine. Sometimes we'll define a region, and sometimes we don't have to define a region depending on the type of operation that we're doing.
Let's take a look at the heights tab. Top height and bottom height are related. Those are the areas in which the CAM operation looks for eligible material to machine. So in this 3D adaptive, I've got the bottom height as a face. If we orbit around, you can see I've selected this face. You can see the blue rectangle, and it's even labeled bottom. So in this case, this CAM operation will not look for any material to machine below that bottom height. It will not look for material above, in this case, whatever the top height is, which we have selected as stock top. You can see that top listed right here in the lighter blue. So the only place this CAM operation will do any work is between the bottom height and the top height. So what is retract height and clearance height? Retract height is the distance the tool moves up when it moves within the same CAM operation. So this is one CAM operation, but you can see it's lifting up and moving over within that same operation. That happens at the retract plane, and you can see that yellow line across this area here. In this case, we defined it as stock top plus 0.2 inches. So then what's their clearance height? The clearance height is where it moves in and out of the whole operation. So this was the first operation in this setup, and you can see it's starting right here with the red down arrow. And when it's done, it moves up out with this green arrow. So when it moves to go into this next 2D adaptive, that is going to occur at the clearance height. The clearance height here is set as the retract height plus 0.4 inches. So we've stacked that height. The clearance height itself is based on this retract height plus 0.4. The clearance label of 0.6 inches represents the clearance over the top of the stock, which is the 0.4 plus the 0.2.
The passes tab, this is what the cutter is doing while it's engaged in the material. This is how much it steps down or how much it steps over. The linking tab, this controls how the tool enters the cut, exits the cut, and transitions between tool paths. For instance, here you can see that if we enter a closed pocket, the tool is going to helix in. However, if I hit the drop down, you can choose pre-drill, plunge, or helix. So you can see how we're controlling how the tool goes into the cut. So hopefully that gives you an idea of what these 5 tabs do. One other thing that I would like to highlight is the great job that has been done to help you understand what's happening in the different dialog boxes. So if I wanted to know what the optimal load was, but wasn't quite sure, if I hover my mouse over that dialog box, you'll notice a nice tooltip pops up and gives me a text description plus a visual description of what's going on. So I hope the description of these 5 tabs helps you to start to understand what these tabs do and where you're going to go to edit your toolpath.